A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com.
Hey Herman and Corn, if you listen carefully you might be able to hear the sound of Air Force jets above us here in Jerusalem. We just had one of the largest salvos of missiles fired by Iran since the start of the war, according to Manny Fabian, who does Trojan work on keeping us updated for English speakers living in Israel. Manny is the Times of Israel's military correspondent, and I don't know if the man has a genetic ability to avoid sleep or just has a lot of coffee at home, but he's reporting around the clock, and the reporting is not only very informative, it's very useful for alerts. He's the only guy I can rely upon to predictably report upon alerts. So I don't know if Manny's cloned himself, so there's like maybe duplicate Manny's floating around the internet, or it's just coffee, but you know, he's doing a great job. Anyway, Herman and Corn, we just got the all clear, and I was thinking again about the challenge of getting connectivity down to an underground shelter, which is has been a persistent challenge when you have the war in Israel. It's actually finally caught the attention of the authorities, or at least charities. The Jewish National Fund is currently raising
Red
money.
Alert! 576 areas active. Nationwide alert count has crossed 500 areas across Israel.
So to make the situation a bit more humorous, I intentionally created my pushover alert that you just heard in a squeaky voice. That was entirely planned. So you just heard there's 500 alerts, which might mean there's another wave, I'm not sure. We'll have to interrupt this. But I don't think anyone is expecting this to be a very quiet evening with the Jewish holiday of Passover starting. The Iranians will almost certainly take the chance to fire more salvos at Israel. And as much as I think sometimes these prompts about preparedness are kind of irrelevant for most people, I feel like they're episodes worth doing, because if we don't talk about this topic, very few people will, and it might just help someone else out. So in that spirit, I was looking at the underground shelter as I came up from it and thinking about how we could actually get connectivity down here so we can actually get these alerts more reliably and not have to sort of think about coming out of the shelter to get signal. And one idea that I had, we talked through before, well, we talked about LoRa. Unfortunately, setting up a LoRa network is not the kind of thing you can do on the fly when the airport is closed, so that's kind of out. Cellular routers are a good option, but I did a little experiment. I tried to get a cellular router at the top of the stairwell. Imagine this is your typical underground municipal shelter, about 3 floors beneath ground level. So we're talking about a lot of concrete, and as Herman and Corn said, for GSM and for cellular, it's not so much the width of the concrete as it is all the little turns and nooks and crannies that any radio frequency is just not gonna. Every time that the radio wave bounces off a wall, it's a bit weaker and a bit weaker, and by the time you get to the place you need it, even if you're only 3 floors underground, you've got no reception basically. So that's what I found when I was trying to do a Wi-Fi network at the top and then run it down. The Wi-Fi actually wouldn't reach even halfway down the stairs because of the concrete, I guess. So the other idea that I had, and what I'd love to get your technical chops for in this podcast, is I was thinking it doesn't make much sense to run even Ethernet down a stairwell. It would make more sense to just have a cellular antenna at the top of the stairs, or your bunker, or wherever else you're sheltering. Capture the cellular where you've got enough of it to sustain a workable minimal viable connection, as we say. That's all we're ever looking for. And then run your cellular antenna cable down to close to where you are, so that you can just position your emergency router, your travel router, your Glynet at that point, and therefore the Wi-Fi will be very close to you, and you can even maybe actually put in a wired connection. So my question, I was thinking, is this feasible? Looking around my tech cabinet, and I thought, wait, yeah, I've loads of, or I've at least one 4G antenna in my tech cabinet. What kind of a urban prepper doesn't have a cellular antenna in their home office? And I remember buying SMA cabling, and it was really cheap. And like you could buy a 20-meter SMA cable for $5 or $10. So my question, Herman and Courtney, is I never actually did this. I do use cellular internet now and again, but I've never actually had need for this big long reach antenna. Is can you actually get a reliable signal? Because I know with a lot of connectivity, HDMI and other networks, with longer cable reaches, you get into signal degradation. You get into, you might have to use repeaters. So do you think that 20 meters is good enough? And I do have an antenna guy, again, who doesn't have an antenna guy in their phone book. Antennas are one of those things you don't want to really import into a country, especially not Israel, unless you know for sure that they're, authorized and allowed. So I think an easier way is to just buy it locally. So I know I found a supplier of these things, a very good company. And if you were to look for a 4G antenna for this use case, to position it, somewhere near the top of a stairwell, run it down 20, maybe 50 meters all the way underground to something like a cellular router, what would you recommend for the antenna and for the cabling? Because when I see 20-meter cabling for $5, as much as I'd love to say, oh, that's really cheap, experience teaches me that there's not really any bargains when it comes to cable quality, and you want to make sure that the cabling you're buying itself is good. And finally, connectivity. These things typically terminate in SMA. What kind of spec would you be looking for on the actual antenna? We see these spec sheets like dB, max dB, impedance, positioning, pointing. What would you go for, Herman and Corin? Over to you two.
Well, that was quite the greeting. If you're wondering about that slightly frantic, synthesized alert tone that just kicked us off, that was actually the custom alert Daniel set out for the latest round of Iranian missile salvos. It's April 1st, 2026, and while most of the world is looking for pranks, the reality in Jerusalem is a bit more high stakes. Daniel just got the all clear from a massive ballistic barrage, and his first thought after making sure Hannah and little Ezra were safe in the shelter was, how on earth do I get a reliable internet signal through 2 meters of reinforced concrete? It's a classic Daniel move. Most people are counting their lucky stars. He's auditing his link budget.
It's a fair question, though. When you're in a mamad or a deep communal shelter, you are essentially sitting inside a Faraday cage made of rebar and high-density concrete. It's designed to stop a blast wave, but it's also remarkably efficient at stopping a 700 MHz LTE signal. And as Daniel mentioned, relying on Emmanuel Fabian's Twitter feed or official Homefront command alerts is a literal lifeline. If you can't get the all clear, you're stuck in a dark room wondering if the thud you just heard was an interception or something worse. By the way, today's episode is powered by Google Gemini 3 Flash, which is helping us parse the physics of this bunker link challenge.
I love that Daniel is looking at his tech cabinet and seeing SMA cables and 4G antennas as the solution. It's very MacGyver in a bomb shelter. But let's get into the weeds here, Herman Poppleberry. He's talking about mounting an antenna at the top of a stairwell, where there's presumably some line of sight to a cell tower, and running a cable 20, 30, maybe even 50 meters down into the depths. My gut tells me that a 50-meter coaxial run for a high-frequency cellular signal is basically a long, expensive way to turn a signal into heat. Am I wrong?
You're not wrong, but the degree to which you're right depends entirely on the grade of the copper. This is where most people trip up. They think a cable is a cable. But at the frequencies we're talking about, anywhere from 800 MHz for long-range LTE up to 2600 MHz for high-capacity bands, the signal doesn't just travel through the wire, it essentially fights its way through. This is called attenuation, or signal loss, and it's measured in decibels per meter. If Daniel uses the standard, thin RG58 cable, the kind you might find on a cheap car antenna, and tries to run at 50 meters, the signal will be stone dead before it hits the halfway mark.
So, it's like trying to push water through a garden hose that's full of tiny holes. By the time it gets to the end, it's just a trickle.
Well, not exactly. I should say it's more like the hose itself is absorbing the water. For a 50-meter run, you're looking at a world of hurt with low-grade cabling. If we look at the numbers, RG58 loses about 0.66 decibels per meter at 900 megahertz. Over 50 meters, that's a 33 decibel loss. In cellular terms, a 30 decibel drop is the difference between full bars streaming 4K video and your phone is a paperweight. You've lost 99.9% of the signal power.
Okay, so RG58 is out. Daniel mentioned he's looking at local suppliers in Israel because the Ministry of Communications is, shall we say, particular about what RF gear gets through customs. What should he be asking for? If he's going to make a 20 to 50 meter run work, what's the gold standard?
He needs to be looking for LMR 400 or an equivalent high-quality, low-loss coaxial cable. LMR 400 is the industry standard for a reason. It's thick, about 10 millimeters, and it's stiff because it has a solid center conductor and serious shielding. At that same 900 megahertz frequency, LMR 400 only loses about 0.22 decibels per meter. So, over a 20-meter run, you're only losing about 4.4 decibels. That's totally manageable. Even at 50 meters, you're looking at an 11 decibel loss. If you have a high-gain antenna outside grabbing a strong signal, you'll still have a very usable connection at the bottom.
11 decibels still sounds like a lot to a layman. If I start with a good signal, what does an 11 decibel penalty actually feel like in the shelter?
Think of it this way. A 3 decibel loss cuts your signal power in half. So, a 6 decibel loss cuts it to a quarter. An 11 decibel loss means you're getting roughly 1/12 of the original power. It sounds dramatic, but cellular radios are incredibly sensitive. As long as the signal-to-noise ratio remains high, the modem can still pull data out of that weak signal. The key is starting with the best possible signal at the top of those stairs. Daniel asked about antenna specs. This is where D/Gain comes in. He should be looking for a high-gain directional antenna, something like a log periodic dipole array, or LPDA.
A log periodic. Sounds like something you'd use to track migratory birds. Why that over a standard shark fin or a little plastic stick?
Because the LPDA is directional. It focuses all its energy in one direction, like a flashlight beam instead of a light bulb. If Daniel knows where the nearest cell tower is, and in Jerusalem, they're usually perched on rooftops or hills. He points that LPDA right at it. A good LPDA will give him 10 to 12 dBi of gain. That gain effectively cancels out the loss from the 50-meter cable run. It's a zero-sum game. The antenna gathers extra energy, the cable eats it, and the router at the bottom receives roughly the same signal strength that was present in the air at the top of the stairs.
I'm imagining Daniel on a ladder at the top of a stairwell, pointing a triangular metal antenna at a tower, while iron dome interceptors are popping off in the distance. It's a very specific vibe. But he mentioned he already has a 4G antenna and some SMA cabling. If that cabling is an LMR 400, is he just wasting his time? Is there any middle ground?
Probably not for a 50-meter run. If he's only going 20 meters, he might get away with LMR 240, which is a bit thinner and easier to snake through tight corners. But for 50 meters, it's LMR 400 or bust. In fact, if he were really serious and money was no object, he'd go for LMR 600, which is even thicker and lower loss, but that stuff is like trying to bend a frozen garden hose. It's a nightmare to install in a residential setting.
Let's talk about the physical installation. Daniel's in a situation where he needs this to be reliable. He mentioned that his Wi-Fi experiment failed because concrete blocks the signal 3 floors down. I think people really underestimate how opaque concrete is to high-frequency waves. You mentioned Faraday cages earlier. How much attenuation are we talking about for a standard bomb shelter wall?
It's brutal. Standard reinforced concrete can easily knock 20 to 30 decibels off a signal per wall. And it's not just the thickness, it's the rebar. The steel mesh inside the concrete is spaced in a way that's almost tuned to block cellular and Wi-Fi frequencies. It's why your cell phone goes from 5 bars to emergency calls only, the second the heavy steel door swings shut. That's why Daniel's idea of a passive antenna extension is actually very clever. You're essentially creating a hole in the Faraday cage and threading a straw through it to suck in the signal.
But his straw is 20 to 50 meters long. If he gets the LMR 400 cable and a good LPDA antenna, he still has to connect it to a router. He mentioned SMA connectors. Is there a risk of losing signal at the junctions? I've seen some of those cheap adapters, and they look like they were made out of recycled soda cans.
Oh, the connectors are the silent killers of RF projects. Every time you add an adapter or a barrel connector, you're introducing a bump in the electrical path. In the industry, we talk about VSWR, voltage standing wave ratio. If the impedance isn't a perfect 50 ohm match all the way through, some of that signal hits the connector and bounces back toward the antenna. It's like a reflection in a window. If you have too many reflections, the signal gets garbled. Daniel needs to make sure his antenna, his cable, and his router are all native 50 ohm impedance. Most home TV stuff is 75 ohms, which is why you can't just use leftover cable from a satellite dish installation. It won't work.
So, no borrowing the cable from the living room TV. Got it. Now, Daniel mentioned he found a local supplier. In Israel, that's likely someone in the Tel Aviv electronics district or a specialized security comms firm. If he's looking at a pointing antenna or something similar, what's the pro move for the router end? Does he just screw the SMA into a cheap travel router and hope for the best?
He should look for a Category 12 or higher LTE router, something like a Teltonica or a high-end Microtik. These are industrial grade. They have better shielding and more sensitive radios than your average consumer grade plug-and-play puck. Also, most modern 4G and 5G connections use MIMO, multiple input, multiple output. This means the router actually wants two antennas to achieve maximum speed and stability. If Daniel only runs one cable, he's cutting his potential bandwidth in half and making the connection less resilient to interference.
Wait, so he needs to run two 50-meter LMR 400 cables. That's going to be a thick bundle of copper. His antenna guy is going to earn his paycheck that day. Is there a way to do it with one cable? Or is that just the price of admission for reliable bunker-grade internet?
If he wants the best reliability for those critical alerts, two cables is the correct way. However, in an emergency, a single high-gain antenna will still give him a solid connection, it just won't be as fast. But for receiving a text-based alert or a low bitrate audio stream from a military correspondent, a single antenna setup is infinitely better than the 0 bars he has now.
Let's pivot for a second, because Daniel mentioned something really interesting. He said his Wi-Fi experiment failed, but he's still thinking about how to get the signal down there. If the 50-meter coax run is too daunting or too expensive, because 50 meters of LMR 400 isn't exactly cheap, what about the active solution? Why not put the cellular router at the top of the stairs in a weatherproof box and run an Ethernet cable down to the shelter? Cat 6 Ethernet can go 100 meters with zero signal loss.
That is, technically speaking, the superior engineering solution. It's much easier to move data over 50 meters than it is to move raw radio waves. You put the cellular router right next to the antenna, maybe a short 2-meter coax jump, so there's almost zero attenuation. Then you convert that to an Ethernet signal and run a cheap, flexible Cat 6 cable all the way down to the shelter. At the bottom, you plug that into a standard Wi-Fi access point. It's more reliable, it's cheaper, and it gives you a perfect signal in the shelter.
So why didn't Daniel do that? Oh, wait. Power. If you put the router at the top of the stairwell, you need to get electricity to it. And in a missile salvo, sometimes the power goes out. If your router is 3 floors up and your battery backup is in the shelter with you, you're back to square one.
Well, not exactly, but that is the primary hurdle. Although he could use power over Ethernet or PoE, you keep the power supply in the shelter and it sends the electricity up the same Ethernet cable that brings the data down. It's a very elegant way to solve the problem. But if Daniel is dead set on the passive antenna on a long leash idea, it's likely because he wants to keep the brains of the operation, the router and its SIM card right where he can see them, safely inside the reinforced walls.
There's a psychological comfort to that, I think. When the world is exploding outside, you don't want your critical comms link sitting in a plastic box in a stairwell 3 floors away. You want to see the little green lights blinking next to you. So, if we stick with the passive coax plan, high-gain LPDA antenna, LMR 400 cable, and an industrial-grade router, what about the all-clear signal itself? Daniel's using these custom alerts. Is there a specific band he should prioritize? I know different frequencies penetrate better than others.
In Israel, the lower frequency bands, like band 28, which is 700 megahertz, are his best friends. Lower frequencies have longer wavelengths, which means they can bend around obstacles better and travel further. When he's shopping for that antenna, he needs to make sure it's wideband, covering everything from 700 megahertz up to 2700. That way, if the cell tower switches frequencies to manage congestion during an emergency, his antenna is ready for it.
And what about the weatherproofing? Jerusalem can get surprisingly chilly, and if he's mounting this at the top of a stairwell, it might be exposed to the elements. I've seen cheap SMA connectors corrode in a single winter.
He needs self-amalgamating tape. It's this rubbery tape that fuses to itself, creating a waterproof, airtight seal around the connectors. You wrap it tight, and it basically turns the junction into a solid block of rubber. If he doesn't do that, moisture will wick into the coaxial cable and it will act like a sponge. Once the inside of a coax cable gets damp, the signal loss skyrockets. It becomes a very heavy, very expensive rope.
A very expensive rope is a great description of most of my failed tech projects. So, to recap the bunker link shopping list for Daniel, a high-gain LPDA antenna, maybe something like the pointing XPO Pol 25G if he can find it locally, 50 meters of LMR 400 cable, weatherproofing tape, and an industrial LTE router with a high-quality SMA input. Is there anything else? What about the positioning part of his question? He asked about dB, impedance, and where to put it.
Positioning is everything. He needs to get that antenna as high as possible. Even a few extra feet can be the difference between line of sight and trying to shoot through a stone wall. If he's in a stairwell, he should try to mount it on the exterior side of the highest landing. And he should use a signal testing app on his phone first, standing at the top of the stairs to find the exact spot where the signal is strongest. Rotate the antenna 5 degrees at a time, wait 30 seconds for the router to update, and check the RSRP, that's the reference signal received power. He's looking for a number closer to 0. Minus 70 is great, minus 110 is, I can barely send a text.
It's funny, we're talking about this as a technical challenge, but for Daniel, this is about hearing his son Ezra laugh instead of worrying about whether a siren is going off. There's something really profound about using weird prompts and technical deep dives as a form of civil defense. Daniel mentioned the Jewish National Fund is raising money for this, which tells you how widespread the problem is. It's not just one guy in a tech cabinet, it's an entire country realizing that modern survival involves more than just food and water. It involves a steady stream of packets.
It's the resilience engineering we talk about. We build these incredible missile defense systems like Iron Dome and Arrow, which are marvels of physics and software. But the last mile of that defense is a human being knowing when it's safe to come out. If that last mile fails because of a 20-cent piece of cheap copper, the whole system is undermined. That's why I don't think Daniel is being nerdy here. I think he's being a pragmatist.
A pragmatist with a lot of SMA cables. I do want to touch on the LoRa thing he mentioned. He said he'd looked at LoRa before, but it's not feasible to set up on the fly. For the listeners who aren't as deep in the weeds as Daniel, LoRa is long-range radio. Very low power, very low bandwidth. It's great for sending a single all-clear message over 10 kilometers, but you can't exactly check the news on it.
Right. LoRa is brilliant for heartbeat sensors or emergency triggers, but it requires a gateway. If the gateway isn't already there, you're just shouting into the void. Cellular is already there, the towers are built, the infrastructure is hardened. You just need to find a way to invite that signal into your bunker.
Let's talk about the fallback options. Suppose Daniel does all this. He buys the LMR 400, he mounts the LPDA, he seals the connectors, and the signal is still flaky. Maybe the nearest tower gets knocked out, or the network is just too congested. Is there a plan C for someone in an underground shelter?
Plan C is usually a passive repeater, but they're notoriously finicky. That's where you have an antenna outside and another antenna inside the shelter, connected by a cable with no powered amplifier in between. The idea is that the outside antenna captures the signal and the inside antenna re-radiates it. In practice, they almost never work well because the signal loss in the cable is usually greater than the gain you get from the antennas. You end up with a signal that is so weak your phone can't even see it.
So, active or nothing. Either you bring the signal down via a high-quality cable directly into a router, or you're just playing with expensive antennas.
And I should mention, Daniel mentioned importing antennas requires authorization. That's a real hurdle. The Israeli Ministry of Communications is worried about people accidentally creating noise that interferes with military or emergency frequencies. That's why buying from a local, reputable supplier is so important. They've already done the legwork to ensure the gear is clean and tuned to the correct Israeli bands.
It's a good reminder that preparedness isn't just about the gear, it's about the legal and logistical framework you're operating in. You don't want to be the guy who accidentally jams the local Iron Dome battery because he bought a signal booster from a questionable website.
That would be a very bad day. And that's the danger of active boosters, the ones that plug into a wall and amplify the signal. If they aren't shielded correctly, they can oscillate, which creates a massive amount of RF noise. It's like putting a microphone next to a speaker. You get that piercing whistle, but for radio waves. A passive antenna and a router, like Daniel is proposing, is much safer and much more likely to be legal.
So, we've given Daniel a lot to chew on. LMR 400, LPDA antennas, 50 ohm impedance matching, wideband coverage, and self-amalgamating tape. It sounds like a weekend project that could literally save a life, or at least save a lot of anxiety during the next holiday salvo. I'm looking at the clock, and I think we've covered the how, but I want to spend a minute on the why. Daniel mentioned that if we don't talk about this, very few people will. Why do you think shelter connectivity is such an overlooked part of emergency planning?
I think we have a set it and forget it mentality with shelters. We think of them as passive structures, thick walls, heavy doors, done. But in 2026, a shelter without a data link is a sensory deprivation chamber. You're blind and deaf to the world outside. We put so much effort into the kinetic side of defense intercepting the missiles that we forget the informational side. But as Daniel is showing us, the informational side is what allows a family to stay calm, to stay informed, and to know when the danger has passed.
It's the difference between surviving and coping. If you're in a shelter for 6 hours and you have no idea what's happening, that's a trauma in itself. If you can see a map of the interceptions, read the updates from Manny Fabian, and maybe even watch a movie with Ezra to keep him distracted, the experience changes entirely. It's civilian resilience through better bandwidth.
It really is. And I think Daniel's approach, using weird prompts to crowdsource the engineering, is a model for how people can handle these high-stress environments. You don't have to be an RF engineer to get this right, you just have to be willing to look at the decibel charts and buy the right cable.
And maybe have a brother who's a nerd about coaxial attenuation. That helps too. Before we wrap up, Herman, any final pro tips for Daniel's antenna guy? Anything he might miss when he's pulling that 50 meters of LMR 400 through a concrete stairwell?
One word, bend radius. LMR 400 is thick, and if you kink it, if you force it into a sharp 90-degree turn to get around a corner, you will crush the internal dielectric. That creates a permanent dead spot in the signal path. He needs to make sure all the turns are gradual, sweeping curves. If you treat the cable like a fragile glass tube, you'll get much better performance.
Treat it like a glass tube. Got it. Well, Daniel, I hope that helps you get the bunker link up and running before Passover. We're thinking of you, Hannah and Ezra. Stay safe, stay connected, and keep those weird prompts coming, even if you have to send them from 3 floors underground.
This is what the show is for. It's taking these high-stakes, real-world problems and finding the technical aha moments that make a difference. Good luck with the LMR 400, Daniel. It's a beast of a cable, but it's the right tool for the job.
We should probably thank the people who make this possible. A huge thanks to our producer, Hilbert Flumingtop, who keeps the gears turning while we're busy talking about signal loss. And a big shout out to Modal for providing the GPU credits that power the generation of this show. We couldn't do it without that serverless magic.
And thank you to everyone for listening. If you're finding value in these deep dives, whether it's about bomb shelter connectivity or the nuances of AI, do us a favor and leave a review on your favorite podcast app. It really does help other people find the show.
You can find all our episodes, including the ones where we talk about survival radios and portable networks, at myweirdprompts.com. We're also on Telegram if you want to get notified the second a new episode drops. Just search for My Weird Prompts.
This has been My Weird Prompts. Stay curious, stay prepared, and we'll talk to you next time.
Catch you later. And Daniel, don't forget the tape. Seriously, the moisture is the enemy.
He's right. Seal those connectors. Bye, everyone.
See ya. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth